Okay, so let's get into solving inequalities. If I say x plus 3 is less than 10, no, hang on here. X plus 3 is less than 10. I'll make a nice number line here. I've got 10, and I don't know where x plus 3 is in comparison to that. When we said x plus 3 is equal to 10, we could line both of these up, move 10, 3 to the left, 3 less than 10 is 7. Move x plus 3, 3 to the left, x plus 3 minus 3 is x. So that means x and 7 are lined up, right? We said these were equal, so these are also equal. But now I'm not saying x plus 3 is equal to 10. Now, x plus 3 could be over here. So when I go 3 less than that, all right, now I have x. That's still less than 7. But I don't know where x plus 3 is in comparison to 10. Maybe it's right here. And I go 3 less than that. I'm right there. X plus 3 is a little bit less than 10, so x is a little bit less than 7. X plus 3 is a lot less than 10, so x is a lot less than 7. I don't know about that distance, but I know wherever x plus 3 is, it's a little bit below the 10, or a lot below the 10, right? But it's over here somewhere. So when that goes down by 3, even if I'm just slightly below the 10, I'm now just slightly below the 7. If I move both sides to the left by 3, that relationship of the left expression being less than the right expression is preserved. Right? And it's the same thing if I moved both sides to the right. If x was right here, and my 10 actually grew by 5, so I'm over here at 15, my x growing by that same distance is still going to be slightly less. Whatever that x was, if I shift that over by 5, it's still less than that 15 going to the left. Now, adding 5 to this statement doesn't really get me closer to x, right? 10 plus 5 is 15. X plus 3 plus 5. Right? Adding 5 to both sides was not useful, but it's also not technically wrong. This relationship is still going to be true. If 3 more than x is slightly or grossly less than 10, 8 more than x will be less than 15. It doesn't matter whether we're dealing with positives or negatives. If everything's shifting to the right, that relationship stays the same. If everything's shifting to the left, that relationship stays the same. So the process of solving inequalities is no different than the process of solving equations. I can still use that additive property whether I start with positives or negatives. So if I start with a new problem here, x minus 5 is greater than negative 7. That's fine. Add 5 to both sides. X minus 5 plus 5, I'm back to x. Negative 7 plus 5, I'm only at negative 2. I'm still greater, right? If I'm looking at negative 7 on the number line, x minus 5 is a little bit more than that. It's not exactly negative 7. It's something more than that. That green is the x minus 5. So if I add 5 to the negative 7, I get to negative 2. My filling in looks kind of like the bumps of adding, so sorry about that. If I also add 5 to my green part, I'm still not exactly negative 2. I'm still more than that, right? Everything's shifting to the right by 5. If I write that here as a plus 5, right? The green part is also plus 5, so it's greater than negative 2. That relationship stays the same. And that's true even if I have x on the right. If I say 7, I'll stop using 7 because it looks like a less than sign. 11 is less than x plus 2. I can subtract 2. 11 minus 2 is 9. Now I have a less than symbol, but notice I'm not saying x is less than, I'm saying 9 is less than. If I look at my number line, if I just want to graph my final answer and not be confusing all the lines here, here's 9. 9 is less than 10, so 10 is good. 9 is less than 15, so 15 is good. 9 is less than 6. No, that's not true. 9 is not less than 6, so 6 is out. 9 is not less than 0, so 0 is out. All of this part is out, all of this part is in. Right? Is 9 less than 9? No, it's not, so I'm going to put the excluding 9 here. Right? I grew most comfortable using the circle, so I tend to use that. I'll try to switch back and forth just to get familiar with using both strategies. Right? Well, what I'm saying by 9 is less than x is the same as saying x is greater than 9. I can just read it the Hebrew or Arabic way, going right to left using the Semitic languages, and it means the same thing here. So with inequalities, we have to be careful about what's on the right side versus the left side of our symbol. It's even more important than usual that we work our way down the page for each equivalent statement, and we don't start putting an equal sign and then simplifying that. All right, so let's look at an example of what I'm talking about there. If I have x plus 3 minus 7x minus 5 is great. I used 7 again. All right, is greater than 11 minus x plus negative 20. I'm not just saying 3 minus 5 equals something. I'm simplifying this expression, x minus 7x, that's a single x here, right? 1x minus 7x, that's negative 6x. 3 does not have any x's, so that's a like term with negative 5. 3 minus 5 is negative 2. Right? 11 minus x, not like terms. I don't know how far less than 11 I've gone, but plus a negative 20, whether I have parentheses around it or not. 11 minus 20, that's negative 9. All right. Now I've got some choices here. Now that I've simplified both sides, I can put those here. Notice I'm not combining the 11 with the 5 or the 3 because it's a different expression, right? Simplify each expression individually. That's our first step. Once we have simplified each expression individually, what's our second step? Introduce the same new operation to both expressions, to both sides. Right? Well, I can either add 6x to get rid of this term, or add 2 to get the identity here, or add 9 to get the additive identity here, or add 1x to get the identity here. Or I could divide everything by negative 6 to get the multiplicative identity for this coefficient. But I definitely don't want to do that. Right? If I get 1x here, that would require 1 over 6 x as a coefficient here. 9 divided by 6 could be reduced, but it's still a fraction. 2 divided by 6 can be reduced, but it's still a fraction. Right? You don't usually want to start dividing until either you're at your very last step, or if you know that division will cancel from every term. So we're not going to divide, we're going to add. Let's say we add 6x to both sides. Right, so whatever value x is, I don't know if it's positive or negative, but I'm adding that quantity to this side. I'm adding the same quantity to the right side, so the left side will remain larger than the right. It'll stay balanced. If I get more here, this one is still going to be lower. When I say balanced, it's not balanced. This is heavier, but it will remain just as much heavier as it was before. So negative 6 plus 6 is 0. 0 times x is 0. 0 minus 2 is negative 2. That's the goal of the identity here. Negative x plus 6x, that's 6 minus 1x. That's 5x. There we go. Now I could have added x to both sides. Especially with inequalities, there's a greater tension here. It's really nice to have our final statement x is to start with x on the left, but it's also kind of nice, which we'll see in a moment, to have my x coefficient be positive. So let's finish this up, change colors here. Now that my x is on the right, I know I need to get rid of this 9, so I add the opposite there. Negative 9 plus 9 is 0. 0 plus 5x is 5x. That's on the smaller side compared to over here. 9 minus 2 is 7. Again, dealing with 7s and greater thans. All right. Now the last step I'm going to do is divide by 5. So 7/5 is greater than x, which means x is greater than, sorry, it's not what I mean. I mean x is less than, let's actually just rewrite this whole thing here. 7/5 is greater than x. 7/5 is greater than x. If I read that from the right, I'm saying x is less than 7/5. If I look at my number line, and I strongly encourage you, even if you are not required to graph it, you're just stating your answer, it's really nice to put the graph just for your own peace of mind, right? X is on the less than side compared to 7/5. So here's 7/5. X is over here going down forever, less than this value. X is less than 7/5. So I can show that in interval notation. Negative infinity. Let's see if I can make that a little bit neater. Alright, it's about as good as I can get. From negative infinity, those should be touching here. From negative infinity on the left all the way up to, but not including 7/5. Right? Now we always use a parenthesis with infinity because x cannot have a value of infinity. You can't add 6 times infinity to negative infinity and get 5 times infinity. It doesn't work that way. Right? Infinity is not really a number, so x cannot have this exact value, positive or negative. So then my graph could also have gone shading everything up to, but not including 7/5 with an arrowhead on the left to indicate that it goes on forever. All right, now let's zero in on this last bit here. 7 is greater than 5x. Let's pick some easier numbers. Let's say 10 is less than 5x. So I've got 10. And here's 0. And 5x is somewhere above that. Right? Say over here. I'll put it up top here so it's not getting in the way. Well, however big that is, it's bigger than the 10. So if I chop this into 5 little pieces, 1, 2, 3, 4, 5, didn't quite line up here. There you go. Pretend those are all the same size. And I chop my 10 into 5 little pieces. 1, 2, 3, 4, 5. Right? Can you see that these pieces, if they're all the same size, have to be smaller than all of these? And if you have a smaller pie, each of your slices of pie are going to be smaller than if you had a bigger pie. Well, that means that this spot here, a fifth of 10, is going to be less than this spot here, a fifth of 5x. I'm getting smaller pieces. And the same thing works with multiplication. Let's say I have the new statement 10 is less than 1/3 x. So I've got my number line, and I have, let's say here's 0, here's 10, that's less than 1/3 x. Well, to get x, what I do, I multiply that by 3. I'm getting 3 of these. 1, let's see if I can be fancy here. Copy, paste. Okay, there's a second one. I'm going to run out of space, I think. Let's shift this over. Okay, so copy this again. Okay, 3 of those. Right, there's 3 1/3 x's. 3 1/3 x's is x. 1/3 plus 2/3 plus 3/3 x. That's where x actually is. Now if I look at 10, and I draw my length of 10, and I copy and paste that one. Alright, get my copies here, line that up. Notice 2 10s is less than 2/3 x's. 3 10s is even more less than 3/3 x's, right? Tripling the 10, getting this as times 3, it is moving to the right. It's actually moved past 1/3 x, but it's growing less than the 1/3 x is growing, right? If this side, if this expression is bigger, tripling that bigger amount gets me further than tripling the smaller amount. So this x is still greater than this 30. And in fact, it's a lot more greater, but we're not measuring how much greater it is, right? I don't know exactly where 1/3 x is. I just know it's more than 10. Right? So if I don't know this distance between the left expression and the right expression, I certainly am not going to know this distance between the left expression and the right expression. But I do know that relationship is still going to be true. Right? And it's true even if x was a negative number. Let's say x is a negative. I got to switch to blue, I guess. Let's say 1/3 x is over here. Right? And x is negative who knows what, but 1/3 x is there. If I triple this, I'm taking this distance and again and again. Oh, I'm making that backwards. 10 can't be less than 1/3 of a negative number. All right, I messed this up. So let's just start fresh here. Start with a new statement. Now I'll say 10 is greater than a third x, right? Where x could be negative. So then I've got my 10. And that's more than a third x, right? 10 is more than this value. So as this gets bigger to the left, 10, which was already to the right, is getting bigger. They're just moving further apart, right? Again, it stays true even if x is negative. So our rules of multiplying still work just the same. What's going to be confusing, and we'll look at this in our next video, is if my coefficient is negative, right? We don't know if x is positive or negative, but if I'm multiplying it by a negative, and then I undo that by multiplying by a negative again, that's going to cause some wrinkles.